In today's video, we will go over how to run a small-scale column chromatography using a pipette. For this experiment, you will need 2 Pasteur pipettes, 2 pipette bulbs, cotton, silica, sand, acetone, eluent, test tubes, and a test tube rack. Column chromatography has 4 parts. First is packing the column, followed by loading the sample, eluting the column, and finally isolating the purified compound. To pack the column, begin by placing a small piece of cotton in one of the Pasteur pipettes. Be sure not to pack it too tightly, or it will make eluting the column more difficult later on. Next, fill the column with silica using the pipette as a scooper. Silica is a respiratory irritant and must be used in the hood. To complete packing the column, add the eluent and push it through using a pipette bulb. To remove as much air as possible, apply as much pressure as you can to the bulb. Do not release the bulb until you remove it from the column. Continue adding and pushing through eluent until as much air as possible is removed from the column. As the air is pushed out, the silica will become more translucent, while the portion that still has air will remain opaque. Once most of the air is removed, the column is packed and ready to be loaded. From this point, the column must not dry out. Keep an eye on the solvent level and add more eluent as needed. In this experiment, the impure sample will be dry loaded onto the column. First, dissolve the solid in minimal acetone. Then add a little bit of silica to the mixture. To remove the acetone, place the mixture on a hot plate set to the lowest setting. The silica may pop as it dries, so use a watch glass as a lid. Once all of the acetone is removed, a free-flowing solid should remain. Once the solid is ready to be added, allow the solvent level to reach the top of the column. Working quickly so the column does not dry out, add about 1/4 inch of the sample. Any more will overload the column and the purification will be incomplete. Tap the column to even the sample, then add some sand. The column is now ready to be eluted. To elute the column, add more solvent and push it through. Note that the eluent can be added to the very top of the pipette and that pushing is stopped before the level reaches the sand to prevent the column from drying out. The solvent coming off the column is collected into test tubes. In this experiment, each of these fractions should be around 4 milliliters. Remember not to release the bulb while it is still attached to the pipette, or the entire column will be disrupted. Continue eluting the column until all the compounds have come off. In this experiment, you will collect 8 to 10 fractions. Spot each fraction onto a TLC plate to see if it contains any compound. For those that do, the TLC should be developed to see which compounds are in it. For example, in these 4 fractions, only 2 through 4 contain compounds. 2 and 3 contain only 1 compound, but fraction 4 has a small amount of a second compound and is impure. To isolate the purified compound, the solvent must be removed. To do this, the fraction is added to a watch glass over boiling water. The heat from the steam will remove the solvent, leaving the purified product as a solid. To successfully run a column, remember the following tips. Don't overload the column by adding too much sample. Stop the solvent before it reaches the sand so the column doesn't dry out. And finally, don't release the bulb before removing it from the column.